Hi, welcome to a new data science project. In this project, we will be predicting Ethereum prices with LSTMs. Let us look at the learning outcomes of this project. In this project, we will learn and understand about a specific class of time series data, cryptocurrency. We'll analyze trends in prices and accordingly build training data, learn about recurrent neural networks and long short-term memory, and finally, deploy our model as a Flask web app. So first let us see what is cryptocurrency. With the recent boom in blockchain technology and digital currency, cryptocurrencies have gained a lot of traction and investors. It has essentially become a variant of stock market trading, making it a variable data scientists can analyze and predict. As crypto is more unreliable and unstable, there has been an increasing demand in services and tools to help in crypto investing compared to traditional stock market analysis. In this project, we are going to employ LSTMs, a form of RNNs or recurrent neural networks, to at least help us understand trends in crypto. So what is Ethereum? Ethereum is a decentralized blockchain with smart contract functionality. Ether is the native cryptocurrency of the platform. Among cryptocurrencies, Ether is second only to Bitcoin in market capitalization. It is open source software. Below we can see the chart for Ethereum close prices taken from the dataset itself. Let us look at the dataset. The dataset can be found on Kaggle. The link is provided. This dataset has hourly entries of data from May of 2016 to April of 2020. The task at hand is to predict the close prices based on previous prices. Let us explore the different features in the dataset and try to understand how we can proceed with model building. Alright, so let us begin with importing important modules. We are importing the NumPy and Pandas library. We are importing matplotlib.pyplot and cbond for plotting, and we are importing math. Let us run this block. Next, we read the CSV file and we pass the dates, which is in string format, to time series format. Now let us print the first 5 values of the data frame. We can see that the starting date here is the last date that is shown in the data set, that is 16th of April 2020. And we can see after that the dates are going back. So obviously this is sorted in a descending order. Other than that, we can see that there's a Unix timestamp, the symbol, an open value, high value, low value, and close value with volume also given. All right. So we're going to sort this data ascending wise so that we have the data from 2016 to 2020. Let us run that. And then we can print the last 5 entries of the data set along with the first 5 entries of the data set. Here we can see now that the data set is starting from 2016 and is going till 2020. So it is correctly sorted. Let's see the data shape. It has 34,497 rows and 7 columns. Now let us check if there are any empty or null values in the data set. We can see that there are no null values in the data set. Now let us check for any duplicated values or duplicated rows in the data set. Again, there are no duplicated rows in the data set. Now, since these two columns, Unix timestamp and symbol, are not contributing to any kind of prediction, as these are the Unix timestamp is a unique value for each row and the symbol is the same for each row, we can just drop these columns. So let's do that. All right. Now we'll plot each column, namely open, high, low, and close. Let us plot that. Okay. Now we'll be creating date time features by extracting the hour, day, month, year, day of week, day of year, and week of year from the time series data. Now using this function, we'll be passing on the data frame in this function. Now making a copy of that data frame, we will use df.index.r function, df.index.day, and so on to create these feature columns. And then finally, we return that data frame. So let us run this code. And now let us pass our current data frame to make a new data frame with the extra feature variables. Let's again print the first 5 entries of the new data frame. Now we can see with open, high, low, close, and volume feature variables, we have also introduced hour, day, month, year, days of week, day of year, and week of year features. Now let us see the correlation between these feature values and our target, which is the close price. So how are we going to predict future unseen values? The main idea behind that is using a rolling window data generation. So here in this picture, we can see for an example, we have taken a data, an array of 10 numbers from 1 to 10. We will be creating a window size of 3 and then predicting after training on 3 samples. So that means initially our training sample will be 1, 2, 3 and our target will be 4. Then our training sample will be 2, 3, 4 and our target will be 5. So the previous target is being appended to the training sample and the initial data point of the training sample is being dropped. Now we are faced with the task of creating or generating windows. We will be generating a 24-hour window to predict the 25th hour using only close. So let us generate the windows. We are taking the entire close column value in this variable close, and we are making 2 empty arrays, windows and target. The length is 240, so that means 24 hours of data is being stored in a window. So let us see the functionality of this for loop. So this for loop is iterating over a range from 0 to the length of the entire data set, which is around 34,000 minus this 240 so that we don't go out of bounds. Now X is the feature samples, that is the samples that will be learned on, and close.iloc from I to I plus length. Basically, this is giving us the entire 24-hour window. So for the first iteration, for example, this will be giving us values from the 0 index to 240 index. This will be stored in the X variable, and Y variable, which is the target, will have the value at 241st index. Now we append this to the Windows list, and we append the target to the target list. Finally, we take a numpy array of windows and we take a numpy array of target, and then we reshape it. Now we'll be using min-max scaler to scale the target and the feature variables so that it is easier for our model to learn. So let us run this. Okay, it has created the windows and the target. Now let us scale the data using min-max scaler. Now we'll be splitting the data into 80% of training data and 20% of testing data. We can't use the normal train test split as this is a time series problem. Therefore, we'll be splitting it manually. The first 80% will be taken as the training data, and the remaining 20% will be taken as the testing data. So here, let us run this code. And then we can see the shape of X train and Y train. So you can see there are 27,405 data points or samples, each of length 240. So that means there are 240 features to learn from. And the target variable has a length of 27405 with one target. All right. So let us plot this data. We can see our training and testing data here. So you can see the blue is our training data and the orange line is our testing data. All right. Let us see what are recurrent neural networks. The basic idea behind an RNN is memory. Regular neural networks like feed-forward or CNNs consider each sample data independent of other data in the dataset. This is why RNNs are very useful for natural language processing and temporal problems, as it considers past data to influence its predictions. Variants of RNN include bidirectional RNNs, LSTMs or long short-term memories, and gated recurrent units. On the right-hand side, we can see a general form of RNN showed. This is resembling a general neural network, except for the fact that there are self-connections to each hidden layer neuron, which is helping to contain memory. So let us look at LSTMs and its implementation. As RNNs usually fail to predict long-term trends in a temporal data, long short-term memory NNs were designed to correct this problem. It comprises of three gates, namely input, output, and forget gates, which help it store useful data over a long range. The structure can be seen in the image shown here. We can see that there is a forget gate, and there's an output gate and an input gate. The memory cell is denoted by G, and the memory cell and the input both contribute to the updation of the weights. We will be implementing LSTMs using the Keras library. Now that we are done with reading our data and splitting into training and testing by creating the features required, let us look into model building and training. So we are going to import the sequential class because our model will be an instance of a linear model. Then we are importing the layers LSTM, dense, and dropout. And finally, we're importing all kind of metrics that we need from sklearn. So we're going to take an instance or an object of the class sequential, and to that model, we're going to add one LSTM layer with 100 neurons, input shape being xtrain.shape1 and xtrain.shape2. That means 240 cross 1. Then we're going to add a dropout layer with zero point 0.2 as the value. That means 20% of the lowest performing or lowest contributing neurons to the output will be dropped. Finally, we add a dense layer with one neuron, which is the output layer with an activation of linear. And we compile this model with the optimizer Adam and loss is equal to MSE. Let us run this. Okay, now we can see a model.summary here. Okay, we can see that there are 40,901 trainable parameters. So now let us fit the model to our training data with 5 epochs. All right, now our model has been fit. Let us plot the history and the loss. Now we can use model.predict to predict the output with our X test. And then we'll have to use inverse transform to get the actual values. Let us run this code block. Okay, now we can show the R squared value, that is the actual score of our model and how well it performs. And we can also plot the predictions according to the actual target value. Let's see. So as you can see, we have got a coefficient of determination score of 96.9%. The actual values are in blue and the predicted values are in orange, and we can see that it has predicted it very nicely. So for future predictions, let us create the model again and then take the entire Windows SC array as the training features and the entire target SC array as the target feature. Now we can fit the model again on our entire data set. Let us do that. Okay, so now our model has been fit properly. So now let us do some testing on this model. So using date time, we'll be creating future steps so that we can test our model for predicting future values. So here, for an example, I am taking the start date as 16th of April 2020, which is the last date in the data set, and I'll be predicting till 30th of April 2020. So using the string, I'm going to convert it to date time, and I'm going to calculate the difference between these two dates using D2 minus D1, and calculate the hourly difference or steps in future using delta dot days multiplied by 24. So let's run this. So we can see that from the 16th of April 2020 to 30th of April 2020, there are 336 steps in the future, or 336 hours. All right. So now let us do an iterative prediction of each future step by using the method that we had described in the image shown in the PPT. So here, f wind will be the last window of the data set, and f target will be the last target of the data set, and new is an empty array. Now, for I in steps in the range of steps in future, we will be dropping the first value of the window and appending the target value to the window for the next prediction. So that we can see that we are doing it here. We are dropping the first value of the window and appending the target value of the next window and reshaping it to make it one sample. Then we are sending this to get our next prediction for the next window using model.predict. After that, we are appending the new predicted target to the new list, and then changing fwind to the current window and f target to the next prediction. So this is a recursive kind of loop which is going to loop through the entire range of steps in future. So let us run this. All right, now we'll perform the inverse. So now let us apply inverse scaling transform to the predicted values so that we get the actual value in dollars. And now we can plot the future prediction. All right, so you can see that there's a very small red line here, and this is showing the future predictions. Let us increase our time space to from 16th of April 2020 to 30th of May 2020. Now we can see that the steps in future is 1056 instead of the 336. Again, we're going to run this code to iteratively predict the next for each future step. All right, now we'll apply the inverse scaling. And then finally, we can plot this. Finally, we can save the model. The LSTM model we can save using model.save, and the scalar model will be saving using pickle. All right, now that we have created our model and made our predictions, let us look at how to create a Flask web app. So I'm going to go to my directory here, app directory. Whenever we are creating a Flask web app, we need to have a certain structure to the directory. Let us look at that. So the static folder here contains all the images that is being input and all the values that is being input in the index.html, and it will also contain the result or the output images to be rendered to the HTML file. The static folder can also contain the CSS file that is used to style our index.html. The templates folder will contain our main index.html file. So let's open that. We can see it's a very small index.html file. The main important part is the form here, which is asking us a to date, like from the last date, which is 16th of April 2020. We can input a to date till when we are asking the model to predict, and then the result is being shown using this image tag here. The result will be saved here in the static folder as static/output.png, and that will be shown here. Other than that, we have an app.py script, which is the main script for making the Flask app, and we have our model.py, which is the main script for making the predictions. We have our model.h5 in the root directory with the scalar.pkl, target.npy, and window.npy all in a root directory of the app. Okay, so now let us go to app.py and see how we're going to create the Flask app. So firstly, we're importing the Flask class to create a new instance of the app. We're importing a render template, which is a function which will render our index.html file as and when required. And then we have the request variable, which will get the values from the index.html form and communicate it to our app.py script. Other than that, we're importing some normal libraries that we have imported in our Jupyter notebook. Another important import here is from the model.py script. We are importing the future function, the base directory, and create steps function. In model.py, we can see that we have the base directory here, we have the create steps function, and we have the future function. So we are importing it here in app.py script so that we can call it as and when required. So let us start with creating a new instance of the Flask app, and then we read the data with pd.readcsv. After reading, as seen in the Jupyter notebook, we sort it in an ascending order. Now we configure the Flask app to show the index.html when it is first loaded using this function. After that, we configure the Flask app to use this function predict when the method get and post have been called. These methods are called when we press the submit button in index.html. Then it will automatically ask the Flask app to call this function predict. So let us see what this function predict does. So here we are requesting a value from the form in index.html with the name td. So here you can see that this name td here, which stores the value of the date, will be communicated to our app.py script. That data is stored in toDate. Now we call the function create steps from our model.py and pass the data to date. So let's see what it does. So here we can see that we have imported a few libraries important for loading our model and testing it. We have also defined a base directory. We have loaded a Keras model using keras.models.load model, and we have set the window length to be 240. Now, one by one, we'll be opening the scalar model using the pickle. We'll be opening the window array and the target array. Now, we come to our create steps function. Here, we get the initial starting date, which is 16th of April 2020, and we get the final date, which is the variable in the data in the variable 2. We use the date time function to create a time series from the string given, and then we create the steps in future using these lines of code as seen in the Jupyter notebook. Finally, we return the steps in future. Now in app.py, we store the steps in future as steps, and then we send it to the future function in model.py. So in model.py, let us see what is the future function. So the future function here is pass the parameter steps in future. And this is basically the same code that we are using in a Jupyter notebook to make our predictions iteratively at each step using the windows that we have generated. Finally, it returns all the predictions to app.py. So here we can see that final prediction is stored in new. Again, we are creating an empty list and appending all the values of close in the data set with the new values so that we can plot it all together. When we are plotting using matplotlib, it always creates a new window which will break the app if we allow that to happen. That's why we write this line of code here to configure matplotlib to not create any windows so that our app doesn't break. Next, we create a figure and we create our plot here. Finally, after creating the plot, we save it in our output in our static folder as output.png, and then ask the function to render the template index.html. So here in index.html, the image that is stored in static slash output.png will be rendered when it is reloaded. Finally, to run the app, we use this block. So now that we know how to create our Flask app, let us run this and see it in real time. All right, so our server is live here on this link. Let us go to this link. We can ignore this image right now because this was generated because of a previous testing. So let us input a date. I will be inputting 16th of May 2020. So that's 1 month into the future. Let us submit this. All right, so here we can see that it has made a prediction as follows.